This is Blockchain 102, episode number 2 in our series called Blockchain 100 series educational videos. I'm Matt Voke, call sign Jerry. Today we're going to be talking about permissioned, permissionless networks. What are the differences there? How can we leverage them in our innovation? These are my perspectives and opinions. They're not necessarily those of United States Special Operations Command or the Air Force. So what are we doing here? What do we need to cover this for? Well, we need to make decisions, and in order to make good decisions, we have to be doing that based on data, information that's valid, that's truthful, most up-to-date, current, etc. But which version of that data is the most current, up-to-date? Who wrote that into the log of history? Was there some tampering, poisoning, etc. going on? How do we ensure that we can't have our adversaries be doing something against our wishes? And then specifically if we're looking at money and other things, that becomes fairly large as well, because there's large incentives to go against other people's version of the truth. So how we'll get after that today is we'll cover some blockchain basics. If you haven't seen my first episode, go ahead and watch the first episode. That covered that a lot more in depth. We'll talk about permission, what it is, some of the strengths, pros and cons, and weaknesses to that. Then we'll talk about some trade-offs in blockchain decision making. What do you need your network to do? And then we'll cover some examples of consensus mechanisms of how you get after permission and permissionless. Basics, real quick, what blockchains are. They're distributed ledgers, meaning you're going to take a knowledge of who gave whom what or who has what, and you're going to put that out in a decentralized nature, so not only I and another individual have a record of the history of truth, but a lot of individuals do as well, so that if there's a discrepancy between us, we're able to solve that quickly. It is basically just a database, very inefficient database, but that distributed and decentralized nature are worth pursuing for a bunch of reasons. It is a chain of cryptographically tied blocks, so that if I adjust one block in the history, each subsequent block is going to be altered, and I can very easily see that. Because it is tamper evident, it is therefore tamper resistant. I'm not going to expend a lot of resources in adjusting the past if it's going to be very easy for everybody to see that I did so and then put that back to the way it should be. It is also trust minimizing or trust transferring. So if I'm going to enter into an agreement with an individual, I don't need to trust that individual. I don't even need to know who that individual is or organization. I just need to know that there's mechanisms in place so that I get what I want and he gets what he wants. What is permission in blockchains? Permission is any kind of control mechanism, and it can vary. It's not necessarily permission, and permissionless isn't necessarily 1 or 0 binary, but they're control mechanisms of who can participate in the network to what extent, who can join, who can view things, who can write things. If I write something different than you, who wins in that argument? And that can differ based on the levels and the control mechanisms that are in place. Some of the pros to a permissioned network are going to be the cons of the permissionless, and then the cons, the pros, and vice versa. But the permissioned network is very efficient for consensus, achieving consensus, because it's a smaller subsection of individuals or organizations or nodes writing to what the history is, instead of thousands or even millions of people trying to decide at the same time what is truth. You're having a small subsection of that. It becomes more efficient. If I don't need everybody working on that version of truth, I can then bucket off individuals so that they can parallel process or store, etc., and that also improves the efficiency. It's also easier to upgrade. If you have one individual running something, he's going to say this is what's going to happen, she's going to say this is how we're moving in this direction, and it's not needed to be voted upon or agreed, and etc. So it's a lot easier to upgrade. And it's very cost effective because you have that smaller section of organizations, individuals, nodes, whatever, that are deciding on that version of truth and validating every single one of those transactions. Whereas you can see some very large fees and transactions, energy cost, consumption on the permissionless networks. Some of the cons: it absolutely requires trust. A lot of people think permission networks are not worth anything because it requires you to trust some set of individuals or organizations, at least more than the permissionless networks. And for that effect, they just say, why don't you just use a database? If you're going to be able to rewrite history, just do it in a more effective and efficient way. And for that reason, it is sometimes censorable. And some you're able to adjust the past in the present, and some you're actually able to go back and adjust the past with the past being adjusted. And that can be pretty dangerous, obviously, with some of the power that goes along with that. In permission networks, the centralized power and authority figures usually get more power and centralization. So for that aspect, it's not exactly seen as fair a lot of the times. The large individuals and organizations maintain, or even a lot of times grow, their power even more significantly. Typically, the closed development is able to run everything. Sometimes the code, for instance, is not even open source or even visible to the public. Obviously some problems there potentially down the road. And with some of these permissioned networks, you can see some collusion if there is a large number of individuals. Sometimes there can be such a concentration of power between them and their incentives so aligned that they collude moving in one direction, which could be at the degradation or against a minority who has no ability to say anything about that. Optimizing blockchains. We optimize blockchains for performance. What do we want in our network? Do we want it to be decentralized and tamper evident and resistant? If we do, we want that to be a highly decentralized network. We want to allow everybody to join that wants to. We want to maximize our censorship resistance. A lot of times with decentralization comes security. We want strong maintenance against malicious attacks. The more nodes that we have out there, allowing everybody to join potentially requires a lot more attackers, in most cases 50-51%, to actually sway that version of truth from what most believe is true to their version of alternate reality. A lot of times that comes at the cost of scalability. So scalability, you can think of either capacity of how many nodes I can have on, how many nodes I can be talking to, or just simple throughput. I can handle X number of transactions per second. For instance, the scalability of Bitcoin, many say, is very challenged because it's only able to handle about 7 transactions a second. That could be bad, but it's because of the high decentralization and high security inherent in Bitcoin. So with this trinity, you're going to play around with where in the triangle you're going to fall of security, throughput, and decentralization. Which do you value? And that'll a lot of times lead you towards a specific consensus mechanism as well. Your consensus mechanism in blockchain is everything. How am I going to get the version of truth written in the blocks onto the chain and make that version out there for everybody and unable to be tampered with? Most common popular version now is called proof of work. I'm going to buy a lot of expensive hardware. I'm going to invest in electricity and running through very complicated cryptographic hashes of data and guessing numbers so that I can guess a hash below a certain difficulty. Once that difficulty is achieved, then I can write my version of transaction history, whatever, onto the blockchain. And then the next is going to be built on top of that. Bitcoin and Ethereum are very good examples of that. Next is proof of stake. So instead of investing all that money in expensive hardware and expensive electricity, which obviously isn't too green, we can talk about that later. Proof of stake basically has the incentive mechanisms aligned for I'm holding a decent amount of this token for this chain. My incentives are for that chain to do well and that token to continue to gain in value. By staking a certain percentage or all of my tokens in that chain, I'm not wanting you to realize that my version of truth that I put on the blockchain is inaccurate with everybody else's and potentially slash that version of truth. That's what Ethereum is attempting to move to in the future. Delegated proof of stake just basically takes proof of stake and minimizes the number of individuals or organizations. So you're going to vote like a representative democracy on who you trust, who you want seeing your version of truth written to the blockchain. PBFT, practical Byzantine fault tolerance, is a lot like individuals talking to everybody, near everybody, so that they can figure out which version of reality is the most likely to be true. Runs into some problems above a third malicious or offline hackers, adversaries, whatever. Round robin, very simple. I'm going to vote on a block, you're going to vote on a block, goes around round robin. Each individual organization node voting on the block, putting that onto the chain. Federated is a pretty good example of a permissioned and effective, efficient chain. I'm going to decide on whom I trust, put those individuals in my quorum, and then that's going to be overlapping other quorums out there so that everybody's going to come to a version of reality with whom they trust, and that's, since it's overlapping with others, it's going to develop the whole network's version of what is truth. And Ripple and Stellar are pretty good examples of those federated systems, but obviously permissioned. So, there we go. That's permissioned and permissionless blockchains. Permission networks are typically ideal, but they are costly. Permission networks control who can participate and what they can do level-wise inside that network. They do have pros and cons, obviously, and we covered those. You need to prioritize what you want in your network. Be very deliberate about that, obviously. And then if you can't decide, the strengths and weaknesses, you can always do a hybrid network. There's an example of a hybrid network where I'm doing all the heavy lifting, most of the work on that private or permissioned chain, and then I can write that version of reality that I agree on in that private or permissioned chain onto the public blockchain, for instance, Ethereum. So that's going to be out there and extremely safe, secure, tamper resistant, that nobody's going to be able to change. That is permissionless networks and blockchain 102. If you would like to see Bitcoin, blockchain 103, that's coming up next. I just have to record that. If you have any questions, if you have any additional subjects you'd like me to cover in future videos, definitely leave that in the comments below. I'd like to see a thumbs up if you like the content. Let me know where you guys want these to head in the future.